something. Like if you go and ask a computer scientist, like a computer engineer, software engineer, he wouldn't know what exactly would be happening in a microprocessor in a deep level, but you being an electronic engineer would know what exactly a software code, what exactly printf is doing on your particular processor or on your particular architecture. So it's always good. Like, and after knowing the C program, as I said, as the world is moving towards automation, it's also not necessary for you to write the entire C program every time. There are scripting languages like Python, which makes tasks easier for you. Like for example, I was recently working on a project where I was supposed to write a Python script to automate something like a creation of C file and then modify certain things in the C file and then execute that file, compile that file, execute it on an FPGA called Z-board, and then try to communicate with the board. And everything should be done just in a click of one Python script. Like I just execute the Python script, and the Python script should generate a C file, and then it should compile, it should execute, it should dump it on the FPGA board, and then also communicate with the board. So everything should have been done using one Python script, and it was my task being an electronics student doing my master's. It was my task to do that, and this was just a part of the project that I was doing. It wasn't the entire project. So if you see, it's always necessary in some way or the other for you to know a programming language, because nobody would come and ask you to write everything in zeros and ones, because there are assemblers that would do it for you. You need not do it. But yeah, and this was about digital electronics. But when you want to continue in the field of analog electronics, you would come across analog to digital converters, digital to analog converters, and different types of mixed signal electronics, where you mostly deal with the signals and waveforms and stuff. But you might ask, like, do I really need programming to design an analog to digital converter or a ladder circuit which has just resistors and op amps and capacitors? Well, maybe no. But in the end, as I said, if you want to automate the process where you want the computer to do things for you, yes, of course, in the end, you would need at least a basic C program or a Python scripting to do the tasks for you. You need not every time open a file to click on run, build, create an executable, and then dump the program into the board or the hardware. Like, you would just run one particular script, and the script would have all the instructions that is necessary. And it just, it just reduces your effort as an engineer. You just have to run the script, and you just have to sit and wait until everything is done for you. So it's just the beauty of the higher level programming languages. Like, it just saves your time, but just that you need to write those scripting languages. Or even if you are not writing, if somebody else has written it. Like for example, if you continue in the field of analog electronics, the combination of physics and analog electronics, you would be introduced to field theory and electromagnetics, which in turn gives rise to power engineering, microwave engineering, RF technology. So in these cases, you would be working more with oscillators, you would be working more with antennas, radars and stuff. And then in the end, you would collect some data, say some waveforms that you will have to analyze, and you can't just sit and look at the waveform and get to know what exactly the waveform is. You need some tools to analyze them, and that in the end can be done using MATLAB, or it could be done using Python. You can record the data, and you can also plot the waveforms. Like for example, with my experience, I did an internship on physical unclonable function. It's based on hardware security. So I had to attack the hardware, and then I had to, using electromagnetic radiations that were emitted from the FPGA board, I had to collect the waveforms. And what should I do with the waveform next? I have to analyze the waveform to see what exactly was happening in the FPGA hardware. So I had to run the scripts, like Python scripts, to analyze what exactly these waveforms are, perform some signal processing on them, and then retrieve the data out of it, and then plot a particular waveform or a particular chart or a heat map to see where exactly the operations were happening on the FPGA processor core. So this was done using Python scripting. So with my experience, I would say it is really important for you to know scripting language at least, so that even if you're concentrating on a field where you may not require an in-depth knowledge of programming, but you would still need a portion of it to analyze your results in the end. So yeah, that's it. And if you if programming is necessary, you might ask where exactly, which level of abstraction you need to work in, or which level of abstraction requires what programming language. So this is just a simple slide which I actually was introduced to in a course called Hardware Software Co-Design during my master's studies. So I thought this would be helpful for you guys to have a look at it. So if you see, system level is the highest level of abstraction, where you basically use some high-level programming languages like C, MATLAB, Simulink, and stuff. Like, it requires some programming here, it requires a lot of programming here. And then if you go one abstraction level below system level, then you would go into architecture, like which particular architecture your laptop is using. It uses x86 architecture, or your microprocessor might use some ARM processor, ARM architecture, or there are some open source architectures available these days, like RISC architectures and RISC-V architectures. So based on that, you might have to know VHDL and Verilog or System-C or MATLAB for hardware side, and for the software part, you will have to know System-C, C++, C, and other electronic design automation programming languages. So if you observe in the entire table, you can see C++ to be the most commonly used programming languages. And if you also want to concentrate your professional life in the field of embedded development, then you would mostly be working in C and C++. You would be writing some device softwares, device drivers. You would be communicating with the embedded board using some C programs. And of course, it's necessary for you to know C, at least a minimum C. And also, I think you were also introduced to C programming these days in your high school, also in your pre-university education, also in your first semester of engineering. You have C programming lab, you have C subjects, and you're already introduced to programming. But it's up to you to develop your skills, continue working on it, because just like any other language, if you're not working on it, you would eventually forget it. So you need to continuously keep working on it to remember something. And if you say, this is another diagram called Y chart, which helps you in knowing the different abstraction levels in hardware software design in electronics, and what basically exists in which abstraction level. So the device abstraction level has transistors, resistors, inductors, and then if you go one abstraction level higher, you would have logic gates, flip-flops, and so on. And depending on this, you would require different programming languages. Like, of course, for transistors and resistors and inductors and capacitors, you don't need any programming language to design them. You just have to physically solder the components onto the board. But when the soldering is done, when you want to communicate with the board, when you want the board to do some tasks for you, say like addition or subtraction or some processing, then you will have to use logic gates and flip-flops and write a Verilog, VHDL, or system Verilog codes. And if you go one abstraction level higher, then you would want some memory transfers to retrieve data from a memory block and then store it in the processor, execute it, and then again store it back into the memory. Then you would require C programming, or again VHDL or Verilog, or it just depends. And if you go one step higher, then comes all the programming languages based on the architectures. And yeah, if you see in every step, you need some programming. Like, it's really important. Being an electronics engineer doesn't restrict you or doesn't stop you to know only resistor, transistors, and inductors. You have something more as well. Like, those are just like alphabets of a language. Resistor, transistor, and inductors are just the alphabets like in any language.